Hello guys, welcome back to another video from the E-Innovators. In this series, we are going to understand the interface of different microcontrollers with the MIT App Inventor. In today's video, we are learning how to build a simple program of turn off and on LED with the help of the MIT App Inventor. We will also make a project how to control the delay of LED with this app. So let's get started. So firstly, what is an MIT App Inventor? It is the open source web application in which we can design the custom application. We design the app with the help of visual programming that allows even the child to build the fully functional app. The block programming language allows us to create complex and high impact apps in less than the traditional time. In our first demo program, we'll be using Arduino UNO, Bluetooth module HC05, LED, resistor and a breadboard. Let's see how to make account and create a new project. First of all, let's see how to build an account on the MIT App Inventor. Firstly, we have to go on their website, which is linked in the description below. Secondly, at their page you can see an icon Create App. Select Account, Page of Terms and Conditions. After read and accept those terms of services, you have your account on the MIT App Inventor. Let's create a project on your app. On the top left, you can see Start New Project. After clicking on that, a small window will appear where you can give a name of your project. By clicking on OK, you can see your project screen. After some time, a new interface will appear on the screen. At your workspace, you have two modes in which one is your designer mode and one is your block mode. In designer mode, you can design your mobile app, and on the block mode, you can do the coding of your app in the block form. First, move towards the designer mode. On left, you have your user interface in which you have components, which you can use in your project. In the middle, you can see a mobile screen or a viewer, which is basically view of your app interface. After that, you will see your used component space, where you can rename or delete them, and in this portion, you can also upload your different media files. At last, you can see the right side of your screen where you can observe properties of your project. And as we have said before, the block mode is for programming. Now let's design our app. First, we have to go to the user interface and select the list picker. This will help you to see which device is available or previously connected. Now select label and drag it to the viewer. This will help us to know whether our Bluetooth is connected or not. Change its width from automatic to fill parent. To adjust size, change its text alignment from left 0 to center 1 and change text to Bluetooth. In bottom left, go to the layout. Here we have different layouts in which we use horizontal alignment. Again, change the width option to fill parent. Drag button option from components section to screen and again adjust the width. For second button, do this button process again, in which one is for turn on and the second one is for the turn off of the LED. Go to the text section in properties and change the name of the buttons. Now we have to add non-visual modules like Bluetooth module. For this, go to the connectivity, select Bluetooth client, and for real-time application, select clock and drag it to the screen. And at the bottom of screen, you can see your non-visible components. If you wish to add an image, select image option from your user interface and drag it to your viewer. On right you can see media section from where you can upload files. After that select image you want to add and select press OK. To adjust width and height you can change your option from automatic to fill parent. In block part we have to select a program to show previous Bluetooth devices to our app. First in the left go to the list picker where select before picking and then select set element. Second go to the Bluetooth client and select address and names. In this part your app will show addresses and name of previous Bluetooth devices which were connected. Now we will make a program to search the new Bluetooth devices. First select list picker, then select after picking. Secondly go to the control and select if then statement. Thirdly go to the Bluetooth client and select call connect address statement and drag it to the if statement. And for then command we have to copy before picking statement. In this part, if any new address is found, it will be a part of the previous Bluetooth address and then show the list of the Bluetooth addresses. To enable the real-time function, we have to use the clock. Now see a program to connect into real time. First go into the clock and select when do clock statement. Then go to the control to select if then statement. Next go into the Bluetooth client and select address and names for if statement and change its position from address and names to its connected. It means if the Bluetooth is connected then change into connected. From label 1 select set text color for then statement and change into text. From text take an empty text box and write connected and change if statement into if else statement. Copy then statement for else if statement and change text into not connected. For functionality of the button, go to the button and drag click. It means when the button is clicked call Bluetooth. In Bluetooth we select send text and for text we select empty text box and write on in the empty text box. Basically this is for on signal. We create another same button for off signal. Here is the program, and one last thing is that the list picker and clock will remain same every time as we interact with the Bluetooth. Just to prevent waste of time, we save these blocks into the bags. Let's download the MIT App Inventor. To test our program, first of all go to the Play Store and search for MIT App Inventor 2 and select MIT AI2 Companion. After installation, open your app. We have to include the on library, which is the software serial. Then we have initialized the Bluetooth module and declared the TX and the RX pin, in our case pin 10 and pin 11. Then declare one variable of string type which will tell us the messages coming from the Bluetooth. In the setup part, we initialize the Bluetooth communication and serial communication and set the pin configuration of pin number 13. Let's move towards the loop part. While the Bluetooth is available, get the characters every 10 milliseconds. This is done with the help of the read function. Now build the character into the string, which will help the program to see the message whether on or off. If the length of the state is not 0, so now check if it is on. So turn on the LED, else turn off, and at the last make the state variable clean. In this circuit we have Arduino, Bluetooth module, LED, resistors and some jumper wires. We connect the ground pin of the Bluetooth module HC05 on the breadboard. so we can ground all the equipments we are using. VCC of the Bluetooth module to 5V pin of Arduino UNO. RX pin of the Bluetooth module to pin 11 of Arduino UNO. And DX pin of the Bluetooth module to pin 10 of Arduino UNO. Connect the negative of the LED to the ground and the positive of the LED to the one terminal of the resistor and the other terminal of the resistor to the pin number 13 of Arduino UNO. Ground the Arduino and provide the supply to the Arduino UNO. Let's transfer this app in your smartphone. Go to Connect option and select Companion. Scan this QR in your smartphone, but we recommend that you download the APK file. Click on the Build option and select App. It will download in your computer and copy APK file to your smartphone. By opening the APK file, the app will open automatically. You will have to open your APK file. To open the Bluetooth module, you must have to open the Bluetooth on your mobile. Then open your app and click on the Bluetooth dialog box and connect Bluetooth module. Now you have the access of the LED. It's your choice to turn it on or off. So guys, let's move towards our second project, which is to control the delay of the LED with the help of the MIT App Inventor. We have to do some amendments in our previous program. We have to choose off button and delete it from here. In this program, we only need one button and we have to include a slider to control a delay. From the thumb position, you can get back to its initial position. From min and to max value, you can change the delay of the slider, and from which you can change its appearance as well. Also, you can change the color of the slider from color options. Now adjust the label. This label will simply show the reading of the slider, and add the button to set up the delay. Now we have to program. If the add delay button is pressed, take the reading of the slider and send it to the Arduino. First go to the button 2 and select clicked and drag it to the code section. Then select Bluetooth client and drag send text. From text we select join method. It has a lot of significance which we'll find in programming part. Select empty text box and join it to the slider thumb position. It says if the button is pressed, call Bluetooth and send text to the Arduino UNO. What next? Whatever is your thumb position on the slider, it will join the delay and delay will always show on the screen. Now one last thing is left. To add the label which will show the reading of the slider. Select slider and drag when to position changed to screen and go to the label and drag set height and change height into the text, and from slider 1 select color right and change it to thumb position. Set it on slide 1, which means if the slider position changed. The label will show the readings of what changes have occurred. The programming will remain the same, we just have to include the delay. Remember, we cannot declare delay because delay is already a function in an Arduino UNO. To make the delay in seconds, we have multiplied it with 1000. The LED will turn on and after given seconds, it will turn off. Let's see how delay function works. In else if part, if the given data is start with the delay, so the whole statement is true and it will execute the else if statement and then replace delay with 0. Let's move towards the block code. Here we can see the importance of join method. If we remove the delay, we only get thumb position, which can also be a floating point to change it into integer. Go to the math. Select round and drag it to the block which round off the decimal value, or we can say change float into integer. Finally compile and run the code of Arduino UNO. You can see if we are giving delay of 1.5, it will give a result 1, and if we give 36, it will show 36 as the result. Let's move towards the demo. Connect the Bluetooth module. We can change the delay using the slider. Here we have set a delay of 9 seconds. The LED will turn off automatically after 9 seconds. Now we are doing this with the delay of 4 seconds. And it is working properly. So guys, that's it for today. I hope you guys liked the video. If you did, please hit the thumbs up and also subscribe the channel to watch our latest uploads as soon as possible. Guys, also visit our pages on Facebook and Twitter and also Instagram. Please follow us on the social media platforms and be a part of the technical family. See you guys shortly in the next video. Peace out.